Good morning, friends. In the last lectures, we studied different problems of the combined stresses, and that's why I am continuing some of the important problems related with the combined stresses. So please note down today's first problems. So if you can solve more problems, or if you are observing, because any lectures that gives actual you can say that is the demo, live demo. So how to solve the problems, how to use the formulas related with the problems. So that's why it is very important to attend the lectures, numerical lectures. Similarly, theoretical lectures also important, but don't miss lectures. Try to attend the more lectures about the any subject. So that's why you will get more knowledge, and if you are getting more knowledge, means you can cash that knowledge in terms of the during the service. So if you are having more knowledge, that reflect during the interview of the your and that may be campus interview, or that may be in industrial interviews. So please note down today's first problems. A column mm by 75 mm has a circular cavity has a circular cavity (37.5 mm) in diameter, as shown in figure. Find the maximum value. Find the maximum value of a load. Of a load that can be applied at an eccentricity of 10 mm with respect to the x axis in order the maximum compressive stress may reach 80 Newton per m squares. So such type of a columns, rectangular columns, this load this is W. W is to be calculated, eccentricity 10 mm, and cavity Yes, this is cavity having diameters 37.5 and this is 75 mm and this is 75 mm. So this load that is to be calculated and the compressive stress. So because in the right hand sides the stress is compressive stress, in the left hand side this is tensile. So compressive stress means positive and this again axial loads means this is compressive bending stress and this is in this areas tensile bending stress. About y-axis in the right hand side compressive bending stress and in the left hand side tensile bending stress and direct stress, that is compressive stress, because nature of the force is pushing types. So that's why direct stress equal to P0 equal to W by A. So first we will calculate area equal to, because this is hollow portions, this portion is the hollow portions, area equal to 75 into 75 or solid area minus hollow area. Solid area 75 by 75 minus pi by 4, 37.5 square, area equal to 37.5 square multiplied by pi divided by 4 minus 75 into 75. This is 4520 mm squares approximately. Next is now sigma b equal to, this is plus minus m divided by now z. Now you know section modulus equal to I divided by y. Y equal to 75 divided by 2, because this is total 75 mm is rectangular sides, means 75y divided by 2. I equal to BD cube basic formula divided by 12 minus pi by 64 d raised to 4. So that's why 75 multiplied by 75 raised to 4 divided by 12 minus pi by 64 37.5 raised to 4. I equal to 75 raised to 3 divided by 12, 2636718 minus 37.5 square multiplied by pi divided by 64, 97,072 equal to minus 2636718 equal to 2539 or 2539 raised to 10 to the power 6 mm raised to 4. Now compressive P max equal to, this is AT equal to direct stress plus PB. Direct stress P divided W divided by area equal to 4520 plus again we have to calculate this section modulus. Section modulus I divided by Y. I divided by 2.539 divided by Y equal to 75 is divided by 37.5. This is equal to 67,723 mm cube. Now you can calculate P max equal to direct stress plus PB, P divided by area, and this is or W by area, and this is PB, W into E divided by Z. W area equal to 4520 plus E, this is 20 divided by 6723, or this is W 4520 plus divided by. So that's why, and this is equal to 80. Now take LCM. And this is 6772 4520 W divided by 4520 6772. So that's why directly I will add that 6772 plus 4520. This is 6772 4520 11292 equal to 80. One divided by answers multiplied by 80 multiplied by 4520 multiplied by so this is equal to W equal to 216.85 kilo Newton. This is your expected answers. W equal to. So this is first problems. Next problems. Try to understand problems. If any doubts related with the problems, you can ask me freely at any times. Only one student is asking me doubts, Somnath. So please try to ask me doubts if any doubts related with the strength of materials, because in the next week we are conducting midterm examination that is based on the 3-4 unit.
So this is second problem. A short column of external diameter capital D and internal diameter small d, which an eccentric load capital W, find the greatest intensity, find the greatest eccentricity which the load have without producing tensions in the cross sections of the column. These columns because this internal diameter D, external diameter capital D, load a short column of external diameter D and internal diameter D, which an eccentric load W, find the greatest eccentricity. So that's why this is E. So in this problems only relations, what is the relationship of the eccentricity, that is to be find out. Now solution, yes, we require its cross sections. This is small d and this is capital D. So that's why first we'll calculate area equal to, because solid area minus hollow area. Solid area equal to pi by 4 capital D D square minus small d square. Alright. So area equal to, you can write y max equal to any distance. So this is y max. So this is y max is the distance of the extreme fiber from its centers. So that's why capital D by 2. Now moment of inertia equal to solid minus hollow. Now both are these are circular sections. That's why this is pi by 64 capital D raised to 4 pi by 64 small d raised to 4. Take common pi by 64 capital D raised to 4 small d raised to 4, or same you can write d square plus small d square capital D square minus small d squares. Right? Now so if only compressive stress is to be produced, what is condition? Direct stress, this is equal to PB. Now direct stress equal to, you can write W divided by pi by 4 capital D raised to d square minus small d square, and this is equal to PB. M divided by IY, M equal to W multiplied by E, I pi by 64 capital D square small d squares and divided by Y equal to capital D divided by 2, or pi by 4 d squares W into E. Same equations we can write. This is 32 into d squares, and this is capital D square small d squares. This W will get cancelled, this pi will get cancelled, and this d square, this will also get cancelled. Now eccentricity equal to or greater than, or this should be less than or equal to now cross multiplications, d square plus, and this is 4 multiplied by 4 divided by this term 32d, or eccentricity equal to 8d. This is your expected answers in terms of the, now eccentricity you will get in terms of the diameters, that is external diameter squares plus internal diameter square divided by 8 into external diameter squares. So this is third problems. Figure shows I am only taking different problems related with the combined stresses. I am not repeating any problems, because repeating the problems means that is the wastage of the times, my times and your times also, because syllabus is bulky. So that's why I am taking minimum number of the problems, but important, and so because of the solving more problems and varieties of the problems, your knowledge will be get more knowledge related with the strength of materials. Figure shows the sections of a, figure shows the sections of a
CI column which carries a load of
120 kilonewton
acting
on a
diagonal of
the sections
at a distance of
50 mm
from the center.
Find the stresses
Find the stresses
at the four
corner at the
four
corners of the section.
figure shown
Four corners A, B, C, D.
if this name is not given,
You can mark that alphabet A, B, C, D, and this is on diagonal. This is load point, and this distance equal to
50
200, 200, 150, 150. And that's why we require, I think, more space. First, we'll calculate load point is at E. Now, this is EY and this is EX. So EX equal to, how you can calculate EX? So we require this angle. This angle, this is EX and this is EY. Tan theta equal to front side, this is 150 divided by 200, theta equal to 0.37.86 degree. So that's why EX equal to front side sin theta equal to EX divided by, because this diagonal equal to 50,
diagonal 50, Ex equal to 50 into sin 36.86. Multiplied by 50. This is 30. Ex equal to 30 mm. Similarly, Ey equal to, because this is Ey, cos 50 into cos 36.86. Cos 36.86 multiplied by 50. This is 40. Now you can solve remaining problems. Now you notes Ex and Ey. This is Ey. What we can do, first we will calculate direct stress. P divided by A equal to, P equal to 120 kilonewton. 120 kilonewtons. Area equal to, this is 400 multiplied by 300. This is equal to 1 megapascal. Next, PB equal to plus minus m by z means P into E divided by I divided by Y. M equal to, okay, that will calculate. Now this is Ixx required. Ixx equal to BD cube divided by 12. B equal to Ixx means this is XX and this is B and this is D. B equal to 400 and D equal to 300. Ixx 400 300 cube divided by 12. This is 9 into 10 to the power 8 mm raised to 4. Similarly, Iyy equal to B equal to now 300, D equal to 400 cube divided by 12. B equal to 300 and D equal to 400. This is Iyy. This is parallel equal to 300 and depth equal to 400. (300) multiplied by 400 cube divided by 12 equal to 16.10 to the power 8 mm raised to 4. Ymax equal to, now we will calculate sigma B, PB equal to m divided by Ixx multiplied by Ex. Ex equal to 40, Ex equal to 30 multiplied by y max. This is y max equal to 150. So that's why directly I am writing here as 150, and this is Ixx 9 into 10 to the power 8 PB equal to this is about XX axis, bending stress about XX axis. Similarly, about YY axis, M into EY into Y max divided by IYY. Sorry, this is P. 120, EY 40, Y max 200, and this is 16 into 10 to the power 8. Right? I think we correctly solve. And divided by answers multiplied by into 40 into 200. This is equal to 0.6 mega Pascal, and XX again, this is also 0.6 mega Pascal. Now, stresses at corner. Stress at corner. Direct stress, bending stress, and this is resultant stress. Remarks: sigma B, or you can say this is PB YY, PB XX, direct stress mega Pascal, mega Pascal, mega Pascal, mega Pascal. Now stress at A corner, at B corner, C corner, and D corner. Direct stress equal to 1. I think direct stress 1 megapascal. This is positive, and PB XX, this is 0.6, this is also 0.6. Now, XX axis, PB XX axis means above A and B. This is load point is above XX axis. So that's why at A corner and at B corner this is positive, and because this C point and D point below the, so no load points. So that's why this is negative. PBY, and this is about YY axis, B and C positive, B and C positive because load point in the right hand side, and in the left hand side at A and D, this is negative. So that's why this is 1 megapascal. This is 2.2 megapascal. Again this is 1 megapascal, and this is 0.2 megapascal, and this negative sign. This negative sign indicates this stress is tensile. This is positive sign, compressive. This is compressive, and this is compressive. I think you understand these problems also. So this is a similar type, but this load points is on the diagonal givens. So this part is the additional parts. So that's why I had taken these problems. And because of the here's you have to find out Ex and Ey, eccentricity about x-x axis and eccentricity about y-y axis. So this is third problem. Due to limitations of the times, again I will take one more problems because I think we complete 40 minutes. A short column of external diameter (40 centimeter) 40 centimeter given, this is, and internal diameter 20 centimeter, carries an eccentric load of 80 kilonewton. Find the greatest eccentricity which the load can have without producing tensions on the cross sections. As shown in figure. this internal diameters 20 centimeters means this is equal to 200 mm, and this is 405. This is load point and this is eccentricity. Again we have to calculate, because this is solid area. Area solid minus a hollow area pi by 400 square minus 200 square, area equal to 94247 mm, because right now moment of inertia equal to solid minus hollow pi by 64 d raised to 4 small d raised to 4. Otherwise we will put as it is. This is d square in the form, right? After that we will see tensions. So that's why PO, this is PB. PO equal to P divided by A. PB equal to P into E multiplied by Y divided by I. P load is given 80 kilonewtons. Area pi by 4 capital D raised to square small d raised to 4 multiplied by E equal to greatest eccentricity means this is E, Y equal to 200 mm, and this is pi by 64 capital D raised to 4 small d raised to 4. So this will get cancelled. This is cancelled. Right. Next, E equal to cross multiplications d raised to 4 divided by 64, and this is also 200 multiplied by this 4 goes in the top side. Small d raised to 4 capital D raised to 4, and this is equal to and d square plus this will get cancelled, right? Now E equal to capital D square plus small d square into this 4 and this 64. 64 means 16. 200. So that's why we can write this is 400 square plus 200 square divided by equal to. So this is greatest eccentricity. 400 square plus 200 square divided by 16 and divided by 200. Now this is equal to 62.5. Eccentricity equal to. And this is your expected answers. Now due to the limitations of the time, I stop here, and remaining portions means remaining problems related with the combined stresses I will take it in the next class, and we can complete this chapters combined stresses. 4 or 5 problems related with these chapters I will take in the next class, and after that we can close these chapters and we can start the another chapters. So that's why today I stop here, and we'll continue the remaining portions about the combined stresses in the next class. Thank you.